All right, so let's go over these population math problems. Number one, a population of 265 swans are introduced to a lake. The population's birth rate is 0.34 swans a year, and the death rate is 0.296. What is the rate of population growth? This is a very basic population growth calculation. These are the ones that you should probably definitely be able to do. So the equation that you would be using is basically the rate of population growth is going to equal the birth rate minus the death rate. All right, so all we got to do is just subtract. So we're going to do 0.341 minus 0.296. And if you subtract that out, you get 0.045. And that's how much the population is going to be growing. And then on your bubble map, and I know I printed them a little bit small, what that would look like would be, it's not negative, so then you would bubble in the point. You would circle that. I'm trying to do that with my finger, it's kind of difficult. And then you would do 0, you would write it in, 0, 4, 5, and actually you'd write in the point, 0.045. And then you would bubble in your 0, your 4, and your 5. I can't do that with my finger, but I think hopefully you'll get the idea. Okay, for number 2, there are 190 frogs in a swamp. The population growth is what R stands for. R equals negative 0.093 frogs a year. That means their population is declining. They are losing a tiny bit of frogs per year. And you're supposed to predict the population size for the next year. So if you have 190 frogs and the rate of growth is 0.093, you're going to multiply that, 0.093 negative, and you multiply that out, you would get negative 17.67. So that means, move this over, you take your 190 and you're losing 17.67 frogs, so you subtract that out. And so you would round and you would get 172 frogs. And then you would bubble that in and you would write, you don't need the points, you can just start on the far 172 and then you would bubble it 172. And that would be it. All right, moving on to number 3. That one, number 2 is also a very basic problem. And the last one that I think is pretty basic would be number 3, possibly 4. But let's go over number 3. A population of 1,492 orioles are introduced to an area in a woods. Over the next year, the orioles show a death rate of 0.395, and the population drops to 1,134. What was the birth rate? So if you looked at your equation sheet, the equation that you should have figured out to use would be the dn dt. When you see the little d, that means change. N is population size, and t is time. And then that equals birth rate minus death rate, and then you multiply that by the population size. All right, so we know the change in population because we know that it is currently 1134 minus 1492 is what happened, right? And that's over 1 year of time. And that equals B, which is what we're looking for, minus the death rate. Okay, the death rate, which was 0.395. And then you would multiply that by 1492, because that's what you're looking for, the birth rate for that population, not the new population. Okay, so then if you calculate that all out, you should get, with doing all the algebra, that B equals 0.155. And then you would bubble that in, and we've shown you this before, 0.155155, and that would finish number 3. Okay, for number 4, the first part is something that you should have figured out from your eco-sit. If there's 780 turkeys and the area of that township is 92 acres in size, the population density would be just 780 divided by 92, which is 8.5 turkeys per acre. The change in population over time, I'm gonna have to do up on the higher part of the problem up there because I don't have enough room. But basically, you take the population. This is a very basic problem as well. Take the 780 and multiply that by your birth rate, which was 0.472, and you would get 368.16. That's your birth rate. And then you take 780 times the death rate, which is 0.331, to find out how many turkeys are dying, right? Because you're getting 368 turkeys being born each year, but then you have a death rate of 0.331, which makes it 258.18. That's your death rate, right? So 258 turkeys are dying for each year. So your change in population would be the difference between that. So you subtract 368 from 258, and you roughly get 110 turkeys per year. And then, so you predict your new population after 1 year. Well, if you get 110 turkeys overall being born per year, and you started with 780 plus 110 is 890 turkeys. Okay, so for the last number 6, the equation's a little bit different because you got to put carrying capacity in there. I already wrote it out there. The change in population equals the R max times n, which is what we did for number 5, but this time you have to take the carrying capacity in there. So you're going to multiply the carrying capacity, which is abbreviated K, minus n, and then divide that by K. So you'd have your 80 times your 40 times 70, which is your carrying capacity, because that's the most dandelions can live in that space, minus 40 divided by 70, and that's how you get the 1371. And so then you would bubble that in is 1371, 1371. Except your bubbles would look a lot better than that. And I hope this is helpful. The only problems that you should probably should be able to do would be 1 through 4. I will not be putting 5 and 6 on your exam. I wanted you to be exposed to them. But 1 through 4 is a basic population math problem.